Hello everyone, welcome to Pepcoding. So in this video we are going to discuss another problem of our stack module, which is check if word is valid after insertion. So firstly we discuss the question, then we move to our approach. So let's see the question. In this question you are given a string at s, determine if it is valid or not. So they are providing us a string, we have to find out it is valid or not. Okay. A valid string is a string that can be created by inserting ABC at any index and any number of times. What they are saying, a string is that can be created by a valid string is a string that can be created by inserting ABC at any index any number of times. So let's understand what they are saying. I am taking it to the whiteboard so that you can easily understand. So this is the line what they are saying. According to this, a string that can be created by inserting. So let's suppose we have a string. This is our string. Inserting ABC at any index anytime. Okay. So we can made a string. We can insert also. According to this, we can insert at ABC at here also. ABC here also. We can insert here also. ABC. There is no limit for inserting and no limit, not any restriction for indexes. We can, if you want insert here, we can insert here. There is not any restriction related to indexes or anything. So that is the meaning of this line. So I hope you understand what is the meaning of this line. Example, in example, ABCD can be created by ABCD. So same thing I repeat in our whiteboard. You can see why it is impossible to create ABCCAB. So what they are saying, I'm taking it here, this to whiteboard. What they are saying, while it is impossible to create ABC, let's try to create it. Firstly we insert ABC, then we again try to insert at here. Firstly I try to insert here ABC. So this is not equal to this one. Then try to insert here ABC. This is also not equal to this one. Try to insert here ABC. So it's also not equal to this one. So this is true. It is impossible to create ABCCAB. So this is a invalid string. This is a good example of invalid string. Okay. Let's see our constant. So in constant, what they are saying? In constant, they are saying S consists of letters A, B, and C only. So in our S string, they are providing a string. We only have A, B, C. We only have A, B, and C. We don't have E, F like this, any character or inverted commas like this. We have only A, B, C in our string. Okay, this is our constant. Let's see our sample input output. So in sample input, they are giving us A, B, C, B, C, A, B, C, and B, C, and the sample output for this one. Okay, so that's all about the question. Let's move to our whiteboard and discuss a question. So in this question, what they are saying that we have a string ABC, and ABC. I will take it as ABC. So this is valid string. Why? Let's suppose we have an empty string. Now we are making string by inserting ABC. and there is no limit for index no limit for using ABC. How many times we want we can use it, and there is not any restriction for indexes. We want, if we want insert at this point, we can insert it. If this point, we can insert it. So let's start for this one. Firstly, we add ABC, then we add ABC here, ABC, ABC. Okay, now we insert ABC, 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 and ABC. Now we add ABC here, so it's become ABC, 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 and BC. So this is valid string. Okay, we find out this is valid string by inserting AB, AB, AB. Then now let's take another example of valid string. A, B, C, A, B, C, A, B, A, B, C, and C. Let's see here. Initially we have empty string. Now we start inserting ABC in this one. So I insert ABC first. Then I insert ABC at here. ABC, ABC. Now I start insert. Now again insert ABC, ABC, and ABC. Now I insert ABC here. ABC, ABC, A, B, ABC, and C. So this is valid. So by doing this, we find out this is valid or not. Let's see an example of invalid string so that you can totally understand what I mean to say. Let's take an example of invalid string. So this is an invalid string ABC, CAB. Okay, so we have empty string. We start inserting in that one. I insert ABC. Now we have CAB. Okay, if I try to add here, what we get? ABC, AB, ABC, C, which is not equals to this one. Okay, now I try to insert here A, B, C, B, C, which is also not equal to this one. Now I try to insert here A, B, C, A, B, C, which is also not equals to this one. So this means this is a invalid string. We tried all indexes, and how many times we add? If we add 2 times A, B, C here, there is no limit of adding. So we also not get this one. So this is invalid. So I hope you understand the difference between valid and invalid strings. So by doing this, we find out which one is invalid and which is invalid. Now what we have to do? We find out a way how we can find the insertion in this string is valid or not. Okay, so let's see. I'm taking another example. This is our string A, B, C, A, B, C, A, B, C, B, C. Now you can see how this one made. We have an empty string. We start adding ABC, inserting ABC in this one. So firstly we insert ABC, then we again insert ABC, then we again insert ABC, then we insert ABC here. So we get A, B, C, A, B, C, A, B, C, B, C. So we get this. Now see here carefully what I am doing. I start iterating from here. I'm start removing ABC from the back, from the reverse, and find out if we get empty string, this is valid, or if we didn't get empty, this is invalid. So this is our valid string example. Let's see. I start removing ABC from the last. So this is ABC. So if I remove this, what I get? ABC, ABC, and ABC. Okay. Now see, I remove second one. I get ABC, ABC. Then I start, and then I remove this one. I get A, B, C in our string. Now when I remove this one, I get empty string. That means this is valid string. What I am doing? Firstly, I start removing ABC from the reverse, remove from the last, so that at the end, when we have last one ABC, when we remove, we get space empty. We get empty string, so it is valid. Otherwise, if it not empty, this is invalid, because it is the combination of only A, B, and C. So if we get empty, this is true. Otherwise, this is valid. Otherwise, let's not valid. Let's take an example of invalid string. Okay. Let's see here. I have A, B, C, C, A, B. Okay. Now see here. I removing ABC from the last. So when find out from the last ABC, this one is the last one. So if I remove this one, I get CAB. Then I again try to remove ABC from the last. We have only CAB, so we cannot remove this. So the size not equals to 0. So size is not equals to 0. So this is invalid string. Now we find out how to check this is valid or not. Now what we have to do? We have to find out a way how can we implement this. For that, let's see here. In the previous questions, what we are doing, we are taking a stack and doing questions related to parenthesis. Same approach, validate parenthesis. So same approach I am using here. I am creating a stack. I am taking it of different color. Okay. I am taking a stack here and taking example of a valid string and see. Now in the previous questions, what we are doing, we have parenthesis, so this come in opening, closing. This is also a pair. Okay. Now in last one, what we are doing, when we have opening brackets and characters, we are pushing them in our stack. But when we have closing bracket, we are popping it out. But we don't have brackets in our string, so we have ABC. So what we do, we remove these brackets, and when we have A and B, A or B, we push them in our stack. Okay. And we have C come in our string, we push it in our string, push it on stack. I'm writing again. Let's see what I'm saying. When we have A or B, we push them in our stack. When we have C, we push it in our stack, and remove. What we do? Remove A, B, C from our stack. I'm again repeating. When we have A, B, we push them in our stack. When we have C, we push C and remove A, B, C from the stack. Let's see here what I mean to say. So we have, firstly, we have A push it in stack, then we have B, push it in our stack, then we have C, push it in our stack, then it's become ABC. What we do? We remove it from our stack. Now these two done. Now come to this one. We have A, then B, then C. So we put firstly A, then put B, push B, then push C. We have ABC. We remove them from the stack. Then these all done. Now we have A, then B, so we add A and B, then we have A, we push in A stack, this is our stack, then we have B, then we have C, so push it out this one, sorry, pop it out from the stack. So we have AB in our stack, then we have again C, we push it, and we have ABC, again we pop it out from stack, so size becomes 0, so it's a valid string. Okay, when our stack size becomes 0, so we can say it's valid and we return true. Let's take an example of invalid string. Okay, so I'm writing A, B, C, C, A, B. Okay, so we have firstly A, we push it in our stack, then B, push it in our stack, when C, we push it in our stack. Then we have to do, what we have to do, we remove them from the stack because we have A, B, C in our stack. Now come to third one. We have C but don't have ABC, so we have to push it in our stack. Then we have A, push it in our stack, then B, then push it on stack. Now string of length of string finished, we reached end of the string. Then we have 3 in our stack, so size is 3, size of stack is 3 not equals to 0, so it returns false because string is invalid. I hope you understand what I mean to say. Now we have an optimal solution for that one. What we are doing, we are adding, firstly we are adding, then we are checking its size, complete the series ABC or not. If it's complete, we pop it out. What if we start checking before adding in the stack or pushing in the stack? Let's see here for this one. Let's see for this one. I am removing this also. Let's see for ABC. This is the invalid one, so this is the best for doing this approach, optimal solution approach. So firstly I remove this so that you can see it. So what I mean to say, when we have AB, we push them in our stack, but when we have C, we do not push this in our stack. We just check if we have B at the top or peak, we pop it out, and then again check. Firstly what we do, we check size, if size is greater than or equals to 0, because when we have AB, the third one is C, so series is complete. So we need at least two characters. So that's why I am saying we are checking the condition, is size is 0, is size is 2, sorry I am right to 2, size is equals to 2 or greater than 2, and then check at the peak of stack we have B. If B, then we pop it out, then check for second one, if it's B, then pop it out, otherwise return false. So we don't need to add or push them in our stack, then check it's complete the series or the size of stack is 0. Let's see for this one. So ABC is completed, then we have C. When we have C, then check the condition, if the size is greater than 0 or equals to greater than 2 or equals to 2, so size is 0, so condition is false, so it's written false, that means invalid string. So I hope you understand what I mean to say. Let's move to our editor and try to code it. So in the editor, what they are giving us a string and a function. Here in main function we have string, which is also we have is valid function. We are passing that string in our this function, so we have to complete this function. So firstly what I am doing, I am creating our stack of character type. And giving it name st, new stack Now what I do, I start iterating from 0 to length of string. Okay, now I firstly take first character of our string ch equals to s dot caret I, then check if we have only two possibility, if it is C or ABC or AB, because we have three characters in our stack. You can see here in our constant we have only ABC. Okay, so we have only two possibilities. It is C, it may be C or AB. So for C, if it is C, what we do? Let's talk about later. If we don't have C, what we do? We simply st dot push ch. Now talk about this one. If we have ch as our character, what we are doing? We are checking two conditions. You can see here. First one, size of stack is greater than or equals to 2, or at the top, at the peak we have B, then we check we have A. If these conditions are true, what we do? We pop them out, otherwise we return false. So if st dot size is greater than equals to 2 and st dot pop equals to B, and now it's pop out B from our stack, then we have to check second. If st dot pop equals to A, then we do pop out. We pop from the stack, but when we are checking this condition, we already popped out A and B, so we don't have to do nothing for this condition. This is for removing A and B. Now in else condition, what we do? Else we just return what we return false. Why we are returning false? If size is not equals to or greater than 2 and at the top we don't have B or A and the second we have A, so the size is 0 or 1, so we don't remove. So we don't remove, like for this one we have C. For this one, what I am saying, size is 0, okay, and the string is invalid, so we return false. At the last, what we do? We return if st dot size is equals to 0. Okay, I am repeating again what I am doing here. I am creating a stack of character type st, then iterating from all over this string, starting from 0 to n length of this string, then take first character of string and check if it's C and do something, otherwise return. Otherwise, if AB, push them in our stack. Then in C, what we are checking, if the size of stack is greater than 2, then at the peak we have B, so pop out. Then check after popping B, we have B, A. After popping out B, we have A, so pop it out, else return false. At the last, what we are doing, if size is 0, we returning true. Try to run it. Okay, I forgot to write this. I try to run it. So it gives us true, compiled successfully. You can see here. You can see in our sample output we have A B C B C A B C B C, same input here, or in output you can see true, same thing here. Try to submit it. So all test case pass, you can see here. So runtime is 0.057 seconds. Memory take uses 10.34 KB. So that's all about the question. If you have any doubt related to question, please write in the comment section, like the video and subscribe our channel. Thank you for watching the video.